In this video, we will graph sine and cosine using period, amplitude, midline, and phase shift. Alright, this is problem number 3, by the way, and this is the function we'll be graphing. Let's start off with the period. Now, the period is always going to be 2 pi divided by b. And this is the b value, the 4, okay? So we're talking about 2 pi divided by 4. 2 goes into 4 twice. So that means the period is pi over 2. Alright, so the period is pi over 2. So let's use the period to label our axes. I like to put the period right here. So this will be pi over 2. If that's pi over 2, then halfway here is going to be pi over 4. Then half of that would be pi over 8. And then over here is always going to be 3 of these. So that's going to be 3 pi over 8. Alright, let's talk midline. The midline is always going to be this number right here. Okay, so that's why the midline is going to be y equals 2. Alright, don't forget your y equals. In other words, a horizontal line at 2. Let's draw that. Now, the amplitude is just going to be this number that's here in the front. So the amplitude, the a value, is just going to be 2. That means I'm going to go up 2 and down 2 from the midline. So keeping in mind that this is the sine function, and the way the sine function works, get to my diagrams here. If you have a positive sine function, well, no matter what, the sine function starts at the midline. If it's positive, it goes up and then down and then back. If it's negative, then it goes down and then up and then back. So we're dealing with a positive sine function, so it's going to go up to the midline, down, back to the midline. So let's do that. Let's execute that. We don't have the phase shift yet, so this will not be the final answer. This is just going to be the skeleton. So let us not connect these dots. So as we discussed, let's put the first point on the midline, and then we're going to go using the amplitude, so it'll be 2 up, and then back to the midline, and then 2 down, and then back to the midline. So this is the skeleton. So that hard part's over. Now we just need to figure out what the phase shift is. Now this would be the phase shift if there was no b value. But when there is a b value, you're going to have to divide. So my phase shift, which I'm going to call PS for some reason, my phase shift is going to be this 7 pi over 4 divided by 4. Now I know that that's going to be 7 pi over 16. Alright, I did that very quickly because I know that when I have a fraction and I'm dividing by a single number, it's just a matter of putting that number in the denominator and multiplying. Okay? Or you can think of it as multiplying by the reciprocal if you like. Or you could use a calculator. Either way, learn to do it fast like I just did. So 7 pi over 16. So this is the phase shift. The direction will be the opposite of what it looks like. So because it's negative, it will actually be to the right. So this is going to be 7 pi over 16 to the right. So our next job is to figure out where 7/16 is along this number line using this scale. And the easiest thing to do, I think, is to use the coefficient, alright, not the pi, but the 7/16 part. Turn that into a decimal to get an approximation. So using the calculator, 7/16. Okay, well, let's just go straight to 7 divided by 16. Alright, so that's 0.4, or round to the nearest tenth, it's approximately 0.4. That makes this phase shift approximately 0.4 0.4 pi. Okay, so that's a little bit less than 0.5 pi, which is pi over 2. All right, so it's a little bit less than half of a pi. Okay, whoa, pi over 2 is the entire thing. That means I'm going to wind up shifting each point almost the entire period. But I need to be as specific as possible. So I need to know how much this mark is right here. So I know, do I need to move it further than this, or exactly this, or less than this? All right, let's figure out what this number is. Well, the easiest thing to do is to figure out what this number is in between, right here at the beginning. If this is pi over 8, then that makes this pi over 16. That means each square is 1 pi over 16. So I can count up from there. This is 2 pi over 16, 3 pi over 16, 4 pi over 16, 5 pi over 16, 6 pi over 16, and 7 pi over 16. So this right here is 7 pi over 16. So that's very useful because that's our phase shift, is 7 pi over 16. Okay, so actually we're going to have to move each one of these points over this much, which is 7 squares. You know, each square was pi over 16, and we did 7 of them. So 7 squares to the right. So see if you can follow this. This first point is going to be moving from here all the way over to here. Okay, so this first point is ending up right here. All right, so here's where I'm beginning. So I don't have to look at each individual point after that and move this 7 spaces. I can begin to follow the pattern of the sine function going up and back to the midline. Okay, so I know my next point is going to be here. You know, you can kind of see the same pattern, see how it's like a diagonal. So I just did the same thing, and then it's going to be back to the midline. All right, and then I'm sort of running out of space because my next point would be down here, and it's off the grid, and my next one is really off the grid. So here's what I was talking about before. So if I want to get more of the graph and I'm out of graph paper, it's okay to go ahead and use a backwards portion of the graph. So I've got these 3 and I could continue forward, but there's no reason not to continue backward since that's where I have space. So continuing backward, maybe I'll change the color slightly to show that this is like what would have been a negative portion of the graph. You know what I mean? If I had done like this and like this, okay, I'm now about to graph, whoops, I missed a little bit. Would have been here. I'm now about to graph this portion, this underneath portion of the graph, and shifting that. So that would look like this. Looking backwards from here, it would go to here, and then back up to here. All right, I know this is a little bit hard to understand, but I just don't know how else to do it. So connecting the dots now, because this really is the final answer. So I'm going to have this, and I'm going to have this. Okay, again, I'm showing this part in purple to emphasize the fact that I had to go negative. This would have been a negative part of the graph before we shifted it. But this is, in fact, one full period of the graph. So I have done what they asked me to do. So don't be afraid to go backward if you run out of space. That's the moral of the story. Okay, so that's it for problem number 3. All right, let's take a look at problem number 4. First of all, the period. You know the period is going to be 2 pi over b. That's how we find the period. So it's going to be 2 pi over 2. All right, this is the b value right here. So that's just going to be pi. So my period is going to be pi. So there you go. I like to put the period right here, so that means this will be pi. If I go halfway, that will be pi over 2. If I go half of that, that'll be pi over 4. And if I triple that, that'll be 3 pi over 4. So that's how we label it. Next, let's talk midline. Well, it's weird because they put it in the front this time. Normally, we'll see that -1 on the end, looking more like this. Either way, that's the midline. So the midline is y equals -1. Let's go ahead and draw that in. Alright, let's talk about the amplitude. The amplitude is going to come from this number right here. So the amplitude is 2. Now, combining that with the midline and the fact that we have a cosine function. Okay, remember cosine works like this. It starts off above the midline and then it goes to the midline, below the midline, to the midline, above. So sort of like a V or like a valley. V for valley. That's great. Whoops. Okay, so keeping that in mind, let's go ahead and draw our skeleton. Sorry, what was that amplitude again? Alright, the amplitude is 2. So that means I'm going to start off cosine above, 2 above the midline. And then I'm going to go to the midline, below the midline, back to the midline, and above the midline. Alright, so 2 above and 2 below the midline. So here is my skeleton of one period of the cosine function. So that's the hard part is now over. All we have to do is the phase shift, alright, either slide it to the left or to the right. Let's calculate. If there was no b value, this would be the phase shift. But when there is a b value, you have to divide. So the phase shift is going to be 7 pi over 4 divided by 2. That's going to be 7 pi over 8. Alright, the 2 just winds up multiplying down here, so 7 pi over 8. You can think of it as multiplying by the reciprocal if it makes you feel better. It's a big multiplication sign, by the way. So 7 pi over 8. So that's my phase shift. Now, it's the opposite of what it looks like. So this will be to the left. And some people like to put negative to signify that we're going to the left. So we just need to figure out how big this is on this particular graph. How many squares to the left is this? Okay, well, if this is pi over 4 right here, then that means this would be pi over 8. Alright, in other words, 1 square is 1 pi over 8. So we need to move 7 of those to the left. Yeah, that's going to be tough because I'm running out of space. I have enough graph to move this one 4 to the left, but not 7. Let's see, this one, I could move 6 to the left. 7 would be tough. So maybe I'll start with this one. In fact, I'll start with this one. Okay, I'll start at the end. I could move this graph, this point on the end 7 to the left. So let's start from there. If I move this guy 7 to the left, it's going to look like this. Alright, so I'm going 7 to the left. So 7 to the left is going to put me right here. Alright, so this point would end up right here. Now the rest of the graph, if I were to graph it, going from right to left, I would go down to the midline, and then below the midline, and then back up to the midline. You know, this graph is trying to do this. Okay, but I'm running out of space. So instead, what I'm going to do is graph the next period over. All right, I'm going to pick up where this left off, and you know, because cosine just repeats over and over again, if one of them doesn't fit, I'll just graph the next one. All right, it doesn't tell you which period you have to graph. You can graph whichever one fits. So this period did not fit. So I'm going to graph the next period over. So I'm going to pick up where I left off and just continue the cosine pattern from this end. So from here, it would go back down to the midline again, and below the midline, and then back to the midline, and then back above the midline again. So instead of graphing that one that I started to graph over there, all right, I graphed this purple period instead. So I know what you're thinking. Wait a minute, Mr. Burton. I thought you said the phase shift was going to be 7 to the left. And here, now that I think about it, what you did was you went 1 to the right. And you're absolutely correct. It turns out a phase shift of 7 to the left is going to be identical to a phase shift of 1 to the right. So I'm glad you noticed that. But that doesn't make it wrong. So this is still just fine. Okay, so let's go ahead and just graph this guy, and it's a thing of beauty. Alright, so I think whenever I don't graph the original one that you would expect, I'll graph it in purple so you know I either graphed the one before it or after it. So I know this is a little bit hard to understand. You'll get the feel of it. Maybe a couple more examples. But for now, here endeth the lesson. Psych, I just thought of something I want to add in real quick here at the end about the phase shift and the fact that shifting 7 pi over 8 to the left turned out to be the same thing as shifting pi over 8 to the right. To just say a little bit more about that, remember that, you know, the sine and cosine function go up and down forever in both directions. So it's really arbitrary what part of the graph we sort of focus our eyes on and graph, you know, because we can't graph everything, it goes forever. But understand this. When you're looking at a periodic function, it doesn't really matter whether this is sine or cosine right now. But if you pick any point on the graph, all right, like take this point right here, for example. If you add or subtract the period to that point, well, the period is the length that it takes before the graph starts to repeat. So if you add the period, then that's going to shift the point from one spot on the graph to the next corresponding part on the graph. So adding the period is going to give you an identical value. You know, if you had a value of 1, it's still going to be a value of 1. If it was a value of 0 and you add the period, period, it's still going to be a value of 0. Alright, so the value doesn't change when you add or subtract the period. So it makes sense that if I'm going to subtract 7 pi over 8, right? Let's focus on that. So minus 7 pi over 8. If I were to take that and add the period, that shouldn't really change the function. Alright, adding the period just puts you sort of back to where you started from. So what happens if I do negative 7 pi over 8 plus pi? Alright, I'm adding the period. Well, this is 1 pi, if you will. So if I wanted to have like denominators so I can really look at it, I could turn that 1 into 8 over 8. So this is really 1 pi is the same thing as 8 over 8 pi. So I'm doing negative 7 pi over 8 plus 8 pi over 8. And guess what? That's going to give you 1 pi over 8. So that's why negative 7 pi over 8 phase shift is identical to a phase shift of positive pi over 8. Because it's like adding 1 period, which isn't really changing anything. So the point of me saying this is the next time you have a phase shift that's so big that it's taking you off the graph paper that you have, maybe see if you can convert that to a smaller phase shift in the other direction by adding or subtracting the period. So we'll watch and see if this comes up again.